Hi, I'm Tara, member of the Teen Advisory Board with Howard County Library System, and today I'm going to be showing you more about classes and objects in Java. So, what even is a class? By definition, a class is a template that describes the data and behavior associated with the instances of that class. As we go through this presentation, I'll be showing you more of what does that definition even mean. As of now, classes have two purposes. 1, to provide functions to do work for the programmer, and 2, to represent data. How can classes provide functions to do work for the programmer? Well, let's think of a really easy example, such as I need something to add two numbers together. Well, here we have a class called addNumbers, and it contains a singular method called the addition method. And this method takes two parameters, first number and second number. And this method adds these two numbers together, returns the final answer as an integer. That's an example of a class. But what about classes in general? What makes up a class? That previous example, you saw that there's only one thing in there, that singular addition method. However, two things can be found in a class, variables and methods. Variables store data about the class, and methods provide programmers with ways of asking the class to do work. We didn't see any variables in that example I showed you, but here is an example where these are class variables, which you can find in these between these orange brackets here. And this is just code for a project I worked on before, which we won't worry about. But here you can see that there are three integers, there's a string array and multiple integer arrays. And there's also a string up here. That previous example, not that lengthy block of code, but the addNumbers class, we saw that it has one method, the addition method. Public static integer addition that takes two parameters, adds them together, returns final answer. However, static, what does that mean? These keyword descriptors here, public shows visibility. We don't know what this is yet, and integer means that this method returns an integer value. It returns answer, and answer is comprised of the first number plus the second number, and is declared as an integer. So it returns the integer value answer. But what does this keyword, what does static mean? So in Java, a static member is a member of a class that isn't associated with an instance of that class. Instead, the member belongs to the class itself. This means you can access the static member without first creating a class instance. I know that's really wordy and really lengthy, and what does that even mean? Well, don't worry, I'll be breaking it down for you very easily through an example of how I can change this previous example to be static and versus what happens when I take out that static instance or that static keyword descriptor. So here is what happens when I take out that keyword static from that addition method. This method in the class addNumber stays the same, still addition method, it still takes two parameters, still adds them together, returns that final answer, but it doesn't have that keyword static in there. What does that mean? Well, it affects us when we create a new class that we want to access the methods and numbers from the addNumbers class. If we don't have static, we can't access it. So when I created this execute code class, there's a public static void main method. It's a main method, and it basically tells the computer, hey, execute the code in the main method, and it go ahead and does that. The change is what you see here in lines 4 and 5, where an instance. Line 4 is an instance. It is a declaration of the addNumbers class, where Think of an instance as a copy. Think of it as a copy. So we just made a copy of the add numbers class that is called this is an instance. So this is an instance class and the add numbers class are exactly identical except in the name. Obviously, add numbers class is named add numbers, and this is an instance class is named this is an instance. It's just a copy. And the only thing different is the name. Line 5 basically says, hey, I want you to print out the value of the addition method when you put numbers 1 and 2 in that is accessed from the this is an instance class. If we tried to put the add numbers dot addition 1 comma 2, if we tried to access the addition method from the add numbers class, it wouldn't work because it's not static. As we mentioned in this previous definition, static allows it to refer to itself. It allows to refer to the class itself. However, because it's not static, we can't do that. What happens when it's static though? What if we just went along and kept that static keyword? Well, the add numbers class still has the addition method, takes those two parameters, adds them together, returns final answer still. That doesn't change. However, it now has the static keyword that it always previously had. So how does that change the execute code class? Well, the main method, instead of having that declaration that you have in line 4 of an instance, which is a copy, instead of making that copy of the add numbers class, you can just refer to it itself. Line 4 says, hey, print out the number that you get from adding 1 and 2 from the add numbers class. You want to refer to the method from the add numbers class. And because we have that keyword static, we don't have to make that copy of add numbers. We can just refer to it itself. Now we're going to move on to the second purpose of a class, which is representing data. And I'm going to be explaining you this concept through a very friendly example, which is the bug, ladybug, spider, and butterfly concept. Think about it as all ladybugs are bugs, but not all bugs are ladybugs. All spiders are considered bugs, but not all bugs are spiders. All butterflies are bugs, but not all bugs are butterflies. And so when I mentioned we were creating an instance in this example, when I said we were making a copy, that is called an object. And much like the definition of an object in the human world, not in the code world, object like a phone, a water bottle, a lamp, objects have a state and behavior, much like real world objects. Let's take this example of a butterfly. A butterfly is red, like its color is red. It doesn't have a pattern. Let's say it's striped, and it has wings. And behaviors it might have, it flies and it drinks nectar from flowers, and spiders as well. Let's say we'll talk about like a specific spider. It's black. Let's say it's black and it's solid colored and it's hairy like a tarantula. And it has certain behaviors like it creates a web and it wraps its prey once it catches it. So objects are very similar to what you would think they are in real life, like regular objects. Like a lamp, it stays on. You can turn it on to give you light, but it's for the most part stationary. Objects are created from a class by making an instance. Remember how I said you make that copy when you make an instance? These are called objects. Instances represent different examples of a class. So this piece of code here, we have the bug class. It has 3 different variables: number of legs, the color, and whether it has wings or not. And these three methods, these just set these values as what they should be. And I'll show you what that actually means. But Here, we can basically say that this code literally created a class. Let's say that box is the class, and this is a template. It's the bug class that doesn't have a specified number of legs, doesn't have a specified color, or doesn't have a specified definition of whether it has wings or not. All we did was declare these variables to exist. After that, these are just methods that we haven't accessed or we haven't executed yet. So it just says, hey, in this bug class, we have num of legs, color, and wings or not, but we don't have any values in them from them yet. So then we have execute bug, very similar to execute code, where there's a main method, and we're declaring the instance of the bug class. We're going to call it ladybug. And we're going to also do that for spider as well. And we're going to set these values to exist. And we're going to go line by line. I'll show you exactly what this means. So line 1, bug ladybug equals new bug. All we did is just create the new class. We created that template. It's called ladybug, and it has the variables num of legs, color, wings or not, but these values aren't set yet. Line 2, ladybug.setColor to red. So in this ladybug class, remember how I said it was a copy, right? We have these same methods. These 3 methods exist within the ladybug class. And it will also exist in the spider class declared later, but these 3 methods exist in the ladybug class. It is a direct copy. The only difference is the name. So it has these, it has the method, and we're going to set the color to red. So ladybug.setColor to red. So in that instance, in that ladybug instance, we're going to set that color to red. So wow, it has a value now. The color is red. The next line of code, we're going to set the number of legs to 6. So we have a value for color, and now we have a value for number of legs, which is 6. In the next line of code, we're going to set the wings to true. Ladybugs do have wings. Now, this also applies for the spider. It'll create another spider class. It'll create a class called spider, which is a variant or direct copy of the bug class, and it'll set it to black. If it had it, it would set it to black. It would set the number of legs to 8, and it would set the wings or not to false. Hopefully this better helped you understand on what classes and objects are, and I thank you for listening to my presentation about classes and objects.